Hello everyone. So for the present lockdown scenario, we are, I'm here to give you a lecture on your course computer networking. Until now we know what is line coding schemes. By line coding schemes we can encode different type of binary data into signals. Following that things we now learn what is block coding. In line coding schemes, we especially encode the digital data into digital signals. Block coding is also similar type of encoding scheme, but here we will encode a block of data into another block of data. Okay, so encoding data into signal is encoding scheme. Similarly, encoding a block of data into another block of data is also encoding schemes. So the difference between block coding and line coding is, in line coding schemes we encode the digital data into digital signals, but in block coding we encode a block of digital data into another block of digital data. Normally in block coding scheme, the encoding schemes are called MB by NB, that is MB/NB, where MB is number of n bits encoded into NB means number of n bits, where m bit is always less than NB. M is always less than n. Okay, so m bit, n group of bit encoded into n bit of group. Okay, so for example, suppose we need to encode A B into using the block coding schemes. So suppose A is grouped into digital data, suppose it is 010101 like that, and B is 110011. So by the block coding scheme, the A will be encoded into some other bit pattern and B is also encoded into other bit pattern, and they then together sent to the receiver's end. Okay, in block coding schemes there are three parts in block coding schemes we have. The first part is grouping, the second is substitution, and the third is combination. Okay, so by grouping it means we are group the data on which we are going to apply the encoding. Okay, that is group. For example, my previous example is that A and B. So when we group A into 110111 like that, so that is called grouping, and B is into another 110 like that. Okay, so that is called grouping. Then the substitution, the main part of the block coding scheme. Substitution is nothing but to change the bit pattern of A into another bit pattern. Okay, so that is substitution. Like suppose A is 110011, then we will change it into 11100001. Okay, so this is the substitution. And the last one is combination. Combination is nothing but after substitution of A and B, we will combine the data and then send it to the receiver's end. Okay, so we will now see different type of block coding schemes, but for the sake of time and for the sake of the scenario, I'll just explain one block coding scheme, that is 4B by 5B block coding schemes, and this will obviously help you to understand all other block coding schemes. Nothing special on the others, all the things are almost similar. So in 4B/5B encoding schemes, a 4-bit data substituted or encoded into 5-bit data. Okay, now 4-bit means we can encode maximum of 16 data. Okay, how? 0000 is 0, 0001 is 1, 0010 is 2, like that. So by that following way, we can encode only 16 bit of data. Now we need to encode it into 5-bit data. So by 5-bit, it means a combination of 32 of data, 32 data types, 32 types of data. By 4-bit, it means 16 types of data, and by 32 it means 5-bit means 32 types of data. Okay, so this is how we can encode 16 types of data into 32 types of data. But 16 types of data cannot be encoded into 32 types of data. So 16 types of data will be encoded into 16 types of data, but the rest 32 bits will be encoded into another things. I'll show you that. So this is what 4-bit by 5-bit. So in 4B by 5B block coding scheme, one and the most important rule is you cannot keep 3 zeros together. Okay, you cannot keep 3 zeros together. Okay, so in suppose this is a data 0000, it means we are keeping 3 zeros together, so that we cannot take it. We need to encode that data. Okay, how? In 4B by 5B block coding scheme, we only can keep 1 0 at the left hand side. Okay, at the leftmost side, maximum 1 0, and at maximum and at right hand side of a data we can keep at most 2 zeros. Okay, so the rule is very simple. We cannot keep more than 1 0 at the left hand side of a data, digital data, obviously binary data, and cannot keep more than 2 0 at the right end of a binary data. Okay, here it is 4-bitted binary data. Okay, now see the examples. So this is the important and one and only rule in 4B by 5B. So here you can see that encoding scheme. So the 4-bit data will be encoded into 5-bit data. Okay, so this is the first 4-bit data 0000, and is encoded like 1110. Look here, 3 zeros, so we cannot keep it. Okay, by the rule, so we are keeping for 1. There is no restriction of ones, so we can keep ones and the 1 0 at the end, and this 0 will suggest the interpreter or at the receiver range that this is the 0, binary 0, 4-bitted binary 0. Now 0001, it will be interpreted at 01001. Look here, only 2. We cannot keep more than 2 zeros, 3 zeros over the intermediate bits. Here it is binary 2, it is encoded like that. Now the interesting fact about the rule, that is we cannot keep more than 3 zeros, it will help in synchronization. Okay, if you recall the MRZI inverse, so there is a problem of synchronization that we, if you keep more zero in the bit or the data, it will create a problem in the receiver's end to detect where the bit ends, where the data ends, a particular data ends. So that is called synchronization problem. And by this scheme, block coding scheme, we can omit or we can decrease that problem of synchronizations. That is what here we can, if you combine any two of data, you never ever find three consecutive zeros. If you try to combine 3 then 2, 3 then 2, okay, first 0 1 2, first 2 and 1, 2 1 21. If you combine 21, now 21 means this is 2 and this is 1. So after 1 0 1 0 0, the next will be 0 1 0 0 1. So here we will have only 3 zeros, not more than 3 zeros. Okay, so by this instinct of keeping not more than 3 zero, the block coding scheme 4B 5B enhance the security also by creating a checking in that data pattern or the bit pattern that there will be no more than 3 zeros. Okay, so I told you that 4-bit data will be encoded into 5-bit data. So the rest 16 combination of 0 and 1, what the utilization of those? The utilization of rest of 16 combination is the control sequence. Okay, here it is 0 2 0 1 2 3 4 5, then you will have 6 7 8 9 10 15. Okay, so now all the 15 is encoded with that, but in 5B portion there is more 16 combination are there. So what to do with that 16 combination? The 16 combination is used into control sequence, and one of them is 0 0 0 0 0, 5 zeros, and it interpreted as quite. Okay, and then idle is 1 1 1 1 1. These are the control sequence used in different the receiver end. That it means if the receiver finds that there is 5 consecutive 1, it means we need to idle here. Okay, we need to halt if it is 0 0 1 0 0. Okay, so this is how 4B/5B block coding scheme works. So this is all for the block coding scheme. The next video or next lecture will be obviously on modulation, and I try to post in your group or try to post through YouTube. So follow that YouTube link, you will have all the things. And if you have any question, feel free to ask me on WhatsApp or can call me or can mail me. Thank you.